You are welcome to our physics practical lesson. Today we are in experiment number 8. If you are not ready for experiment number 1 up to experiment number 7, subscribe our channel, like those experiments, allow notification for the coming lesson, and at the end of this lesson give us a feedback, give us a good comment, some questions you can ask through a comment, and we will see how those experiments have been solved your challenge. Our aim is to see how you have been solved your challenge through these experiments, and to see you perform very well those experiments. So today we are proceeding with the experiment number 8. We're looking some experiments in physics practical. Now we are in a topic of current electricity. Our aim of experiment for today, you are required to determine the resistivity of a wire. There is different wire. There is constant wire, there is nichrome wire, and a different gauge or SWG, standard wire gauge. So experiment number 8 will look about this circuit. In experiment number 7 previous lesson, you can find it through that Skillslearningnetwork, our channel. You see experiment number 7, we talk about this circuit. It means there was EMF, standard resistor over 2, and a current. We have resistivity wire. Even this resistivity wire, there is a resistance. So we have 2 resistors in experiment number 7. But for today, experiment number 8, we are going to remove this one resistor. We are going to remove this one resistor to this side. So how we are going to solve this question with the one resistor of resistivity wire only? That is our circuit, and that is our experiment number 8. Procedure of this experiment: take readings. The main procedure, you take readings or you record the readings of current by varying the length of wire from 20 up to 100 centimeter. And when you perform experiment, make sure leave the key open throughout the experiment. That is the main procedure within our experiment. It means you vary the length of W, length of wire, and you record the value of current through ammeter. And remember, we have internal resistance through that battery. That is our procedure. The questions which can appear through that experiment: number 1, plot a graph of 1/I against the length of wire. Number 2, calculate the slope of the graph. Number 3, using the EMF of a battery, and find the resistivity of wire, and find the internal resistance R of the battery. Those are questions can be asked, or you have to solve those questions. The question C, you have said using the EMF of a battery. So which EMF? The important thing here, EMF is the voltage when the current are not flowing through that battery. It means we have to take a voltmeter to measure the voltage, the EMF of that battery before performing the experiment. It means when you record the EMF after experiment, it means it will be not exactly. So make sure you record the EMF of a battery before performing experiment or before connection of that battery. That is very important point. Then after recording the data and to see that those questions, let me proceed the main concept of experimental theory of experiment. We look our circuit. We have to drive the equation which obey this nature of a graph. 1 over I is y and the L is x axis. So our circuit is that one. So remember, we have one resistor of wire. So the general equation according to our circuit would be EMF is equal to current R of wire plus internal resistance of a battery. So you are required to plot a graph of 1 over I against the length of wire. So you have to dissolve or to drive the equation up to reach 1 over I y-axis and the L which is x-axis. So we proceed on derivation. EMF is equal to current RW plus R internal resistance. So 1, that is current, is equal to EMF over R plus R. In order to get 1 over I, you have to make a reciprocal of this equation. Then 1 over I is equal to RW over E plus R over E. Then we have to, in order to get the length of W, we have to apply resistivity formula, which is this one. Resistivity of wire W is equal to area of wire times the resistance of wire over length of wire. It means you equate resistance of wire is equal to resistivity times the length of wire over area of that resistivity wire. Then area is equal to pi d square over 4. So instead of putting area, we have to use pi d square over 4. So resistance will be this one, resistivity times the length over pi d square over 4 is equal to, it means resistance will be this equation, this one. Okay, so resistance of wire is equal to pi resistivity times 4 times the length of wire over pi d square. Then general equation will be 1 over I is equal to resistivity times 4 times the length of wire pi d square over EMF plus R over E. So that is LW. 1 over I is read as y-axis, and it means we are going to remove L to be out of this equation. The general equation will be 1 over current is equal to pi is equal to resistivity times 4 over pi d square times EMF times LW. You see our general equation, which obey the nature of our graph, 1 over I against the length of wire plus R over E is this equation, and this obey the nature of the graph. Y is equal to mx plus c. Y-axis is equal to 1 over I. Slope is equal to this, resistivity times 4 times over pi d square times EMF times 4 times the length of wire plus R over E, which will be y-intercept. You see, according to the nature, our slope is positive and our y-intercept is positive. So the graph will be a straight line passing through y positive axis. So the nature of the graph will be as you see. That is our graph. We cut through or pass through y positive axis. It means which is a straight, when it is straight line, it means it will give the positive slope. Y-axis is equal to 1 over I, x is equal to L, length of wire, and the slope is equal to resistivity times 4 over pi d square times EMF, and the C is equal to y-intercept, which is equal to R over E. Then we are required to find the internal distance of a battery. So from the nature of this graph, we have seen that internal distance is obtained from y-intercept, which is this one. It means in order to get the CY-intercept, we are going to read the value of intercept of this value from the graph. Then we are going to substitute to this formula. EMF measured before experiment. Generally, R is equal to EMF times Y-intercept. It means EMF is equal to 3 volt times Y-intercept, which will use your graph as you recorded in data. If you have data, it means the graph will be simple to plot. And then to find the resistivity of wire. Resistivity obtained from slope. Resistivity times 4 over pi d square times EMF. EMF you have, which is 3 volt, and the resistivity of wire will be pi d square times E times the slope over 4. It means when you have a data, you will induce to this formula and you will be able to calculate the resistivity of wire. I think you have seen that is experiment number 8, and I have enjoyed about our derivation. I think now we end up here for experiment number 8. For the coming lesson, we are proceeding with the experiment number 9. Subscribe our channel, give us a comment about this lesson, like and share more to your fellow to solve this challenge in physics practical. Thank you for learning with me.